notebook out. Let's put that away for now. And let's write today's date. I don't remember the last time we took notes.
It was in March.
All right. Notebooks. All right. Squares. Squares and square. All right, squares and square roots. Squares and square roots. Today is squares and square roots. Now, the first part, the squares, you should actually already know. Okay? So, you should know this by now. 1 squared. What is 1 squared?
2.
Ruben? 2. No.
Oh, 1.
No.
Oh, 1 times 1.
It's 1 times 1. So it's 1.
Anything by 1 is always going to be.
Yep. 2 squared. 4.
9.
You're literally creating an answer key for later's, the worksheet that you're going to get later. This is like the answer sheet. 1 squared, 2 squared, 3 squared.
9.
I think so. 4 squared.
9. I mean,
16.
12.
16. 4 times 4 is 16.
Oh, yeah. Is that a 4?
5 squared.
25.
Nice. 6 squared. 7 squared. 8 squared.
64. I knew that.
9 squared. 81. Writing this down. The more you write, the easier the worksheet will be in about 2 minutes. 10 squared. 100. All right, we're going all the way to 15. Yeah.
Oh gosh.
11 squared. No.
121.
121. 12 squared.
144.
Nice. I probably still will go into the 2nd grade class, which is across the hallway over there, and tell them, like, if you can memorize your times tables this summer, math will be easier for you. Because a lot of you struggle with math because you don't know your times table. So if I tell the 2nd graders, hey, 2nd graders, all you have to do is memorize your times tables. And math will become so much more easy.
Friday, you should let us help them out with that.
They help you. No, not you, but I'm just saying, even though you're like, oh, let me help you, and then they end up like, no, what are you talking about? 13 squared. What's 13 squared?
169.
14 squared. 2nd grade.
200.
186. 196.
196. 15 squared.
I think it's 200. 235.
225.
276.
It's 225 here.
Yeah, that's what me and Ruben said.
No, I did not. I did not say 35.
She did say no.
I did not say 35.
Like the 5th answer you gave me? Yeah, sure.
I said 25.
All right, so these are your squares. Now, make sure you have all this down. The more you have, the easier the worksheet will be. Now, let's talk about the opposite, square roots. So, does anybody know what the square root symbol looks like?
No.
So,
Looks like a division, but it's like a V, and then it goes up, and then I think.
yeah, so it looks like a division symbol, but it has this extra little
It's like a chair.
tray. So this is called a square root. This symbol is called a square root.
How is that division?
That's not my math testing. I didn't understand.
How is
Yeah.
that division?
So these are
Oh, I've seen that.
square roots. The traditional division for Reuben looks like this, right? Elementary style, right?
Oh, okay.
So they look similar,
I
right?
thought you meant the symbol.
No, this symbol, I guess I should say. So it's called a square root. It's called a square root. This is the opposite of squaring. So, for example, if I ask you, what is the square root of 25?
5.
The answer would be 5. Okay, let's see if you can figure this out. What if I ask you for the square root of 100?
10.
10. So what are square roots?
Oh, it's basically they
Backwards
give you that.
It's division backwards.
Divide by
Backwards
two.
division.
So, well, we're not dividing by 2, right? Because that would be 50, right?
Yeah.
These are the answers to what you just wrote down.
Yeah.
Right? So I can do right here
You multiply.
the square root of 9. 3. The square root of 16.
4.
The square root of 4. 2. So basically you have the answers of the squares and you do the opposite. Kind of like, what's the opposite of adding? What's the opposite of multiplying?
Dividing.
What's the opposite of squaring?
Square root.
Square root. Or what's the opposite of square root? A square. So those are opposites. It's like a new operation. Like you learn how to add, subtract, multiply, divide. Now the next operation is squaring and square roots, which you'll use in 8th grade and in high school. So why is this the way it is? No, I don't just. Oh no. Whatever. It's cool. It's fine. Don't worry, Miss Lamelli. Okay. The square root of, what did we say? 25. Now, wait, yes, I know it's 5. In 6th grade, you learned how to, you factored. Remember doing that?
Oh yeah.
5 and
When
5.
you go like that, so it said times you, so it would show how it equals it.
Yeah, so what gives me 25?
5 and 5.
5 times 5. So in square root, it's like, what's the number that repeats itself to make this number? Oh, what number repeated?
5.
The 5, so therefore your answer is 5. That's how this works.
It's always repeated.
Yeah, you're looking for the number that repeats. So for example, the square root of 36.
6.
Because it's
Does it repeat by
6 times 6. Now, is 36 also 4 times 9?
No. Oh yeah.
I mean, yes.
Yeah.
It's not the
But it
square
doesn't,
because
it's not the same.
It's not the same, so I can't do that, right? So we're looking for the numbers that repeat. We're looking for the numbers that repeat. Whatever number repeats, when you factor it, that's the number that you take out. Anyways, good job. Good job for those of you who are following along. All right, now let's build another table next to it. So, what's the square root of 1?
1.
What's the square root of 4?
2.
What's the square root of 9?
3.
Square root of 16. Square root of 25. So do you guys see we're taking all the answers and we're putting them into the squares, and your answers are your bases, what you started with. Square root of 36, square root of 49, 64, square root of 81, square root of 100,
So would you put the division, like the simple division sign?
No, you have to practice fancy dancy. Look, you start like that, then you go down, then you go straight up, and then you go across. Some kids said it was like the hospital, like the heartbeats.
That's what
The monitor.
Monitor, yeah.
There we go.
Heartbeat.
The heart rate.
Yeah.
That's what I was thinking of.
I could
She
see.
goes
Yes,
it
I
up.
was.
Thank you.
Square root of 169 is 13. Square root of 196 is 14. Square root of 225 is 15, right?
Only by 1, 2, 3, 4, 5.
Yeah. These are your basic ones, right? These I hope you have memorized by the end of 8th grade. Most of you do have memorized like up to 12. So you just want to add 13, 14, 15 into your memory. I used to have my kids memorize all the way to 20. But, you know, those were the old days. Yeah, this was 7th grade math before. When I first started teaching.
They get mad at you
What?
when they go to somewhere.
They moved it up to 8th grade.
Miss Cotto made us do flashcards.
Aw.
I hate flashcards.
I never
Alright.
understood math.
Cause then there's that
It's
one
not
kid that wants to win so bad.
I practice in my
Wait, 25?
25. So 20 and then 25. There's 5. Those two separate.
Oh, 25. Oh. 25 times 20 and then 25 times 5?
So that's 500 from and then 125.
And then 625?
I practice on the always. It is.
Okay, okay. All right, what are we doing next? We're doing the worksheet, right? Yeah. All right. I'm like, what am I doing?
Yo no sé.
Okay, here we go. You're going to use what you just. Oh, actually, hold on. All right, ladies, gentlemen, here's what I want you to do. This worksheet, for 1 minute and a half, don't use your table, Desiree. How many can you answer without? Just testing you.
Okay.
Just how many can you do? You're going to use the table later, but how many can you use without the table? Set timer for 1 minute and a half. So, how many can you do? Thanks. Without looking. Without looking for 1 minute and a half, and then we'll look. So it's just like, hey, how many can you do? Just testing yourself. No, I'm not grading it. How many did you do or not do?
I like it.
Make sure you're on the front side with the squares, not the square roots. So how many can you do without looking?
Oh, wait, this one?
Oh, yeah,
The common square?
Yeah.
Oh, no.
How many can you do? Yeah, without looking. How many can you do? There's some easy ones like 5 squared. You should be able to do without looking. So how many can you do? If it's a couple, it's a couple. That's cool. Make sure it's not tomorrow because everything will close tomorrow. That, yes, but tomorrow when I'm absent, it's all due within that period. All right, we're going to take some notes. Notes. All right, I would like to introduce to you. Do I have them here? Did I lose them? Like to introduce you to Pythagoras.
Who is that?
Pythagoras.
Oh, it's the guy who made the something theorem.
Yes, very good.
The same.
So Pythagoras was born about 270 BC.
That's like 100 years ago.
Are we in history now? No.
That's like 7 billion years ago. Miss, wasn't that like before the dinosaurs?
570 BC, so that's over 2,000 years ago. Said to have passed away around the age of 75. So this is a Greek mathematician. He developed a lot of math theorems. One of his famous math theorems is called the Pythagorean theorem, which I'm going to show you today. Pythagorean theorem involves a right triangle like so. And he discovered that if you square the numbers, kind of like what we just did, squaring the numbers, you would find the missing side. So he developed this math equation, a squared plus b squared equals c squared, for a right triangle, which is pretty cool that he did this back in the day, even without a calculator. Imagine, he did this without a calculator.
I'll probably do that.
Totally. So, let's title it Pythagorean.
Why'd you spell like that?
Who knows? And I always misspell it. Pythagorean theorem developed by Pythagoras. I'm assuming it's called Pythagorean for Pythagoras. Alright, this involves using a right triangle. A right triangle. It only works with a right triangle. So we create a right triangle in our notebook with the 90-degree symbol, symbolizing that it is a right triangle. Alright, so he called this the leg, this the leg. So the two lines that make up the 90 degrees, he called the legs. And then this, what do you think he called it? You would think.
A leg.
You would think. Nah, he came up with his own name. Hypotenuse. Hypotenuse. So it's kind of like he called leg, hypotenuse. Don't ask me why. Maybe it was lost in translation. I don't know. We could do a whole research project for the last 7 days of school and realizing, the history behind Pythagoras. It's called leg, L-E-G, leg, L-E-G, and then hypotenuse, H-Y-P-O-T-E-N-U-S-E.
There's a 90-degree angle. Like for hang time, like they just go straight up, and then I realize this is like a down angle. So like this, and I'm like, wow, the 90-degree angle is like, wow, yeah.
I can do that.
And I thought, and then it's like,
So 90 times 90 plus the A to the B.
Alright. So, yeah. I'm assuming it's ABC because of the alphabet, but the Greek alphabet's a little different, so I don't know. A squared plus B squared equals C squared. So he developed this formula, this equation that always works. So, if you are given a right triangle like this.
Miss, but why did he choose like out of all like the letters? Why A, B, and C?
like a variable, right?
Mm-hmm. So he chose the variables A, B, and C instead of X and Y. X and Y are
Who chose X and Y?
X, Y, Z.
Was it like Albert Einstein?
before.
Albert Einstein's
Can you
grandpa.
sit down? Miss, can you put it more
Can you explain a Fortnite term?
So, A squared plus B squared equals C squared. So this was developed over 2,000 years ago, when there may or may not have been even a ruler back then. All right? Yes, a dinosaur. All right. So, which number represents side A?
3.
Which number represents side B?
4.
Which number represents side C?
21.
No.
X.
X. Okay? So, A is 3, B is 4, and C is X. C always has to be opposite of the 90 degrees. A and B can be switched. So, A is 3, so we're going to substitute 3 squared plus 4 squared is equal to C squared. So, you're trying to find the measurement of C, this length. But you don't have a protractor, a compass, a ruler, nothing. All you have is A squared plus B squared equals C squared. So now that we plugged in our numbers, we get to do the math. What's 3 squared?
9.
What's 4 squared?
16.
Equals
21.
c squared.
25.
25. 25 squared?
25 square.
So we add this up. 9 plus 16. 25 is equal to c squared. That's cool. But is that my answer?
No.
No. You see this little square there? I don't want it. I want to get rid of it.
625.
No.
Bro.
No.
You divide it?
No.
You square root it.
You square root it. So you see how it has the exponent of 2?
I just guessed.
I don't want that. I want to do the opposite of squaring. Today, you learn that the opposite of squaring is square root. So we're going to write the square root of c squared and the square root of 25. Whatever you do to one side, you have to do to the other side. Like when we were drawing the bars, remember that? Like this, right? You're going to get c by itself. Okay, trick question. What is c? What's the square root of c squared?
1.25.
C.
5.
No, I asked, what's the square root of c squared? It's just c. You get rid of the little 2.
How? How do you get rid of the 2 though?
The square root takes it away. All right, what's the square root of 25? 5. I'm not done. I'm way not done. Like, not at all. 5. So the measurement of c is 5. All right. All right, let's do another right triangle. I got 6 minutes, kids. Plenty of time.
It's kind of confusing.
3. True. All right. Do I expect you to have this memorized with the first example? No, my job would be a lot easier. Okay, x. 8 inches, 6 inches. Okay? Which one's side A?
8.
I mean 8.
Does it matter? No. Which one's B?
6 inches.
Sure. But this one's the one that matters. C. C will be your x. It has to be the opposite of the 90. That's the one that matters. A and B don't really matter. You can switch it. So let's substitute the numbers. What do I write down?
Wait, could x be a different number?
6 squared plus 8 squared.
6 squared plus 8 squared is equal to c squared. All right, let's look at your table. What's 6 squared?
36.
What's 8 squared?
64.
Now you add these two. 36 and 64.
100.
It is 100. Now, is that my answer? No. What's the last thing I have to do?
Square root it. 10.
You look at your table.
It's 10.
C is equal to 10. The square root of 100. So the reason I taught you square roots today was because we need it for Pythagorean. All right, your homework is going to be due on Wednesday.
So I get like 1 day to do it?
Remember, how many homework assignments do we get this week?
1.
1. And this one's going to be due Wednesday.
Can I actually